and we're back doing hypothesis testing with two samples. And this one is one of my favorite lessons, two dependent samples. They use this all the time in the medical community, and it's just really neat to see how it works out. It's very practical, very useful. Let's go. The t-test for dependent samples is also known as the paired t-test. Instead of comparing the means of two samples, we are interested in the difference for each pair. One of the most common dependent tests is a before and after test. Both populations must be normally distributed and randomly selected, and the samples must be paired. If those conditions are met, we can use a t-distribution. And for the hypotheses, what we're going to be doing is we're going to be comparing the mean of the differences, that's mu sub d, to 0. So we'll dive right in. A state legislator wants to determine how much the use of social media changes her ratings. The following table shows the legislator's performance rating from the same 16 randomly selected voters before she started using social media and after she started using social media. At alpha equals 0.01, is there enough evidence to conclude that the legislator's performance rating has changed? Assume performance ratings are normally distributed, and we're going to use p-values. Now remember, we're interested in the differences. So that's the first thing we're going to find, the differences. And in this case, here's how we set up our hypotheses. The null is that the differences equal 0. The alternate is that the differences don't equal 0. We've got a 0.01 significance level, t-distribution, two-tailed test. So our rejection rule is going to be if p is less than 0.01, we'll reject the null. If p is greater than or equal to 0.01, we'll fail to reject the null. Pull up your calculator. And the first thing you're going to do is take these lists and put them in. List 1 will be before social media. List 2 will be after social media. And then we're going to use list 3 to find the differences. So if you go up and highlight L3 and in there, put that you want it to take list 1 and subtract list 2. Hit enter and it'll pull up all the differences for you. Then go to stat tests, down to t-test, and then highlight data. And in data, we're going to say that we're comparing the differences to 0. We're using list 3 and we're doing a two-tailed test. Now pause this just a minute if you need to make sure you get all this in your calculator correctly. Once you have all this in, you hit calculate and find the p-value. In this case, our p-value is about 0.19. 0.19 is greater than 0.01, so we fail to reject the null. That means we're accepting the null, so it's likely that the legislator's use of social media did not change her performance rating. The CEO of Doodads believes that playing music will increase the productivity of his workers. So 13 doodad makers are randomly selected and their productivity tracked for 2 months. During the first month, the employees listened to upbeat music while they worked. During the second month, the employees worked in silence. Below are the results. We're going to use p-values and test the claim at the 0.10 significance level. So again, first thing we need to do is find the differences. We have a bit of a problem though. This is not a two-tailed test. And if it's not a two-tailed test, then setting up the hypotheses is a bit trickier. So here's a hint, and this is what I want you to ask yourself. If D is the difference, that means it's the first score minus the second score. So what is the CEO hypothesizing? Well, he's hypothesizing that there's an increased, not equal, but an increased productivity with music. That means with music would be the bigger number. So the difference between the first and the second would be positive. So the CEO is hypothesizing that the mean difference is greater than 0. And that becomes our alternate hypotheses. Mu sub d is greater than 0, which means that our null is that the mean of the differences is less than or equal to 0. Once we have those set up, it gets a bit easier. We're doing a significance level of 0.10, t-distribution, right-tailed test. If p is less than 0.10, we'll reject the null. If p is greater than or equal to 0.10, we'll fail to reject the null. Pull up your calculator. List 1 is with music, list 2 is no music, and list 3 again is the differences. We're using a t-test, and under data, we're comparing it to 0, again using list 3, but this time a right-tailed test. Hit calculate and find your p-value. In this case, our p-value is about 0.003, which is less than 0.10, so we'll reject the null, which means it is likely that music increases productivity. One more. RAISE is a 2-hour course that advertises improvement on a participant's SAT scores. The table shows math scores for 14 students on their initial SAT attempt and their second SAT attempt after participating in RAISE. At alpha equals 0.05, is there enough evidence to conclude that the students' math SAT scores improved the second time they took the SAT? Assume the population data is normally distributed and use p-values. Again, let's pull up the differences to get started. Our hint, first score minus second score, what is RAISE hypothesizing? RAISE is hypothesizing increased scores after the course, which means that test 1 would be the smaller number. So the differences would be negative. RAISE is hypothesizing that the mean differences is less than 0, and that becomes our alternate hypothesis. The mean difference is less than 0. Our null hypothesis is that the mean difference is greater than or equal to 0. We're doing a 0.05 significance level, t-distribution, left-tailed test. If p is less than 0.05, we'll reject the null. If p is greater than or equal to 0.05, we'll fail to reject the null. Again, we'll pull up our calculator. The first test goes in list 1, the second test goes in list 2, and list 3 is the differences. Again, we're comparing those differences to 0 using list 3. We're doing a left-tailed test. This time we get a p-value of 0.005. Since 0.005 is less than 0.05, we'll reject the null hypothesis. In this case, that means that it is likely that the student's performance on the SAT improved. Like I said, this is a really cool test, and they use it all the time in stats. But be really, really careful how you set up those hypotheses. Ask yourself, what that mean difference at the bottom, am I expecting it to be negative? Am I expecting it to be positive? Really think through that before you set up your hypotheses, and then you'll be good to go. Good luck. Have a great time. And thanks for being here.